Okay, I'm hopeful that you've got through to your class learning now. And paying attention to the board, we're just going to do a very quick catch-up. Stop your chatter, please. Going to do a very quick catch-up on what we were looking at on Friday. Ben, I'll come to you and talk with you. But remember we spoke about knowing what common multiples highest factors are of certain numbers, all right? So it's about knowing our times table, Damon, Liam. Yeah. It's about knowing our times tables are very important. And they use a tactic of red colour. It might be a tactic that you use. It's really easy to see what the common themes are when we're trying to compare two things, all right? A reminder that it started slowly. It started in a very basic fashion. Find the highest common factor of 8a and 12b. 2 times 2 is 4, 4 times 2 is 8, 2 times 2 is 4, 4 times 3 is 12, so that all works. Times a to get 8a, times b to get 12b. They aren't similar to each other, so the only common factor is 2 times 2 being 4. And when we looked over here, this said 4 or 2 times 2 times x. And this one said 2 times 3 times x times y. The common factors there are the x's underlined and the 2's underlined. Ultimately, what we're aiming to look at is to actually bring it back so that we're going the reverse of our distributive laws. So if we go back to our distributive laws being this here, you're asked to expand that in all of exercise 5. All right, so you're asked to multiply that by that and that by that, give you 3x plus 6. We're factorising now. We're going back the other way. We're trying to find what the common factor is of these numbers and letters. All right. I do like the way they've done this because they've started slowly with very basic computations. The highest common factor of 3x plus 3, x plus 3 and x plus 1. Okay, so what you can see is that they separate this. Okay, so they just take that on its own to start with. All right, and try and break it down. What that's saying is 3 times x plus 3. And then they try and break this down. Again in red is the highest common factor of x plus 3. That's the only common factor. So here, let's try this one. That'd be 3 times b plus 6. Would look like that. Yeah. And then this one is b plus 5, b plus 6, b plus 5, oops, b plus 6. The common factor is those two there. Okay, so we're just trying to break down what is there. We're just saying to ourselves what we've got in each of these scenarios. That's probably where most of you are. Is there anyone beyond 3? It's one of you. Sorry.
What was the question?
Is there anyone beyond 3?
Yeah.
Yep. So I'll let you get back on it now that we've refreshed, used a bit of a number game to wake us up for a Monday. And shuffle your cups if you require any further assistance from there. Ben, I'll come to you, mate. All right, so we're looking at G, this one here. So it's the same as before, trying to outline what you've got. So in 42, you'd have 7 times 6. And in the 35, you've got 7 times 5 times x. Is that right? Yep. So the common factor of 7 will go at the front. And then you've got to make it so that it becomes out to be 42 take 35x. So how could you get a number on its own to equal 42 under this circumstance?
7 plus 6.
Yeah, yep. So where would the 6 go?
In the brackets.
Yeah, anywhere? Over here or here?
Doesn't matter, probably first.
First, just to stay consistent with this, because 7 times 6 would get you your 42, wouldn't it?
Yeah.
Alright. So we've done that.
Yeah.
And what are we left to do?
35, negative 35x.
Negative 35x. How could we get negative 35 out of this?
So, it'd be 5x would be 1. Would that be correct? It'd be negative 5x in the brackets.
Negative 5x. Yep, you're on the right track. Okay. The great thing about this is you can check it, because we've done the expansions. Okay. So if we were to check it, we'd say everything inside is multiplied by that which is outside. 7 times 6 is 42. 7 times negative 5 is negative 35 x. And that's exactly what you started with. Okay? So find what the commonality is, and that goes out the front. And then it's a matter of saying, well, how can I make this work out of what I can put inside of the brackets? All right? Okay, just like your pencils down, please, I just want to go through 8b. 12b question. Where did we go before, Will? That was back there, wasn't it? 12b1. So most of you will be heading towards 12b. You'll notice that in... so what they're asking you to do here is fully factorise it. Okay, they're asking you to fully factorise. And so let's just take C for a second. It's very important that you pull this apart and pull this apart before you try to fully factorise. Okay, and I mean fully pull it apart in terms of what's a common factor of 10 and 30. So you're looking at the numbers. And what you've got here, of course, is 10 times x. You've got a take there. Graham, can you pay attention, please? And then what's a common factor of 10 for here should be your thinking, Caitlin. So what you'd have there is 10 times 3. 10 times 3 would give you 30. Okay? 10 times x would give you 10x. So you should be able to identify from that the common factor is 10. Okay? And so the common factor 10 has to go out the front of the brackets. We're using distributive law 1 here. And we know there's a times in here. So to multiply 10 by something to get 10x, what do we have to multiply the 10 by to get 10x, Charlotte? Yep. What do we have to multiply the 10 by to get 10x? It'd be multiply it by x.
Yeah.
So you just put an x in there, and that would achieve us this. Okay? Now the next part asks us to get negative 30. If we've got 10 out the front, how can we get it to equal negative 30? Jordan? We just have a negative 3 there. 10 times negative 3 achieves us our negative 30. So we're finding our common factor being 10 and putting that out the front, and then filling up the brackets with whatever it takes to make this ring true. Let's do 42 take 35x. So we pull it apart first. If we pull apart, what's the common factor of 42 and 35, Maddie? It's going to be a problem. Luke?
7.
Our 7's going to 42. 7's going to 35. If we're working with our 7's, Caitlin, how many 7's go into 42? You're not the only one in here that doesn't know that, but it's really, really petrifying me that at year 9. 7 times 6. That's right. Good girl. That's right. We've always got the calculator there. All right. 7 times 6 gets us 42. What gets us 35? Will?
7 times 5.
And times by x would give us 35x. Damo, pay attention, please. So again, we're looking for the common factor. The common factor is 7. So 7 goes out the front of your brackets. Okay? Your eyes should only be focused on making this happen. How can, by timesing it by 7, how can I make 42 happen? Put a 6 there. 7 times 6. Remember, there's a times here. 7 times 6 equals 42. And then I need to make this happen. Negative 35x. What could I do there, Tisha?
Negative 5x.
Excellent. Negative 5x. I've got to make that happen. We're using distributive law 1. I said to Will before, I think it was Will, the beauty of this stuff is you can check it. You know distributive law 1 exists, so apply it. 7 times 6, 42. 7 times negative 5, it's negative 35x. Is that what I started with? Yes, that's what I started with. I must have this right. Okay? So, it is scary that you got to year 9 without knowing your times tables. However, we can only work with what we've got. The important thing is, as I said before, when you had trouble with your number lining, alright, those that were fair dinkum about doing well wrote a number line in the back of their book and used it. Those same people will have a calculator by them or have a times table from their diary in front of them. Use them. Okay? If you've made it to year 9, well done. If you've made it to year 9 without knowing your simple times tables, even better. Good work, but we're going to need to know them. Or just have your diary out in front. Use what you got. Yeah? Be a problem solver for yourself. Alright, in your own learning. I hope that helps. That'll be on YouTube for you to look at.